What's up, fam? This is Coach Knight one more time. Gonna go over today how to do and use some trigonometric identities. We're simplifying them today. Over here on the left of the screen, you can see these trigonometric identities. Now, believe it or not, this is not all of them. This is the ones that we're going to be using for this lesson. And we're actually not even going to use all of them. We will be focusing on the reciprocal identities, the quotient identities, and the Pythagorean identities. So we're only going to be kind of using those three types. And to simplify trigonometric identities or expressions, there's a couple rules that you need to know. Besides just memorizing these, and the more familiar you are with these, the easier these problems are. Basically, to simplify them, I kind of live by two basic rules. I'm going to try to make one. I'm either going to try to make everything into sine and cosine if I can, and two, I'm not going to forget how to just math. What does that mean? Well, that means like I'm not going to forget how to factor and how to divide by fractions and things like that. That's what a lot of times what trips us up on these type problems is we forget how to just do math, just basic math like fractions and factoring and multiplying and things like that. So just so you know, these three sections of identities are what we're focused on in this lesson. And here we go. I've got 4 examples over here. You can find these on the internet, examples to do. There's a lot of them. So without further ado, we're going to start with number 1 here. All right. And again, my first step is to make everything either sine and cosine, or for this problem, you can factor because they both have a sine of x, so that is the greatest common factor. So if you take that out, you will be left with the sine of x times 1 plus cotangent squared of x. And all I did was factor that out to the front. Now, I'll change my highlighter here. Now, we have this in parentheses, 1 plus cotangent squared x. And what you need to always kind of remember to help you familiarize yourself with them is when you see a square, you need to think Pythagorean identities, which are these right here. Okay? Think Pythagorean identities when you see something squared. Now, you can still change everything to sine and cosine if you want, but a lot of times when it's something squared, you're going to be using one of these bad boys. And if you will notice, 1 plus cotangent squared is right there, and it says it's equal to cosecant squared. So I can change that to cosecant squared, sine x times cosecant squared x. And now I can change cosecant squared x to sine. Right here, sine of x equals 1 over cosecant, or sine of theta, I should say. Theta and x are the same thing. It's just a variable. A lot of times in trig, if it is a Greek letter that you're using, that means that's just telling you it's an angle. So my example problem, we're just using good old x. In the identities, they're using theta for all of them. So no big deal. Sometimes they'll use theta, sometimes they'll use alpha, as you can see there. Sometimes they just use A, as you see there. So beta is also one that they use quite a bit. So don't let the difference of the identity or of the variables mess you up. So I'm going to change this cosecant squared x to 1 over sine squared x, because sine is equal to 1 over cosecant, which means cosecant equals 1 over sine. And since it's squared, it's 1 over sine squared. And then we're almost done. this will be sine x on top divided by sine squared x. Well, that is 1 over the sine of x. And like I just said, we just used it. Sine of theta is equal to 1 over cosecant of theta. So 1 over sine of x would be equal to cosecant of x. And now it is simplified. Okay, let me erase all this so I can highlight if I need to. All right, example 2. This one is a little more straightforward. You got cosecant theta divided by the cotangent of theta. So I'm going to follow my basic rule of trying to change everything to sine and cosine because I don't have any squares. So Pythagorean identities, using those would not be useful here. Basically, I just need to figure out what can I change cosecant to and cotangent to make it sine and cosine. So if I come over here, the cosecant one is easy. I'm going to use this one. Okay. Sine equals 1 over cosecant. Well, that means cosecant equals 1 over sine of theta divided by cotangent. Now, cotangent here would be 1 over tangent of theta. It says tangent of theta equals 1 over cotangent of theta, so that means cotangent of theta would be 1 over tangent of theta, but that's still not sine and cosine. So if you'll check out these quotient identities right here, it will tell you that the cotangent is equal to cosine over sine. So that's what I'm going to replace it with, cosine over sine. So this is cosine theta divided by sine of theta. Okay, and from here, basically, we just do math. We are dividing a fraction by a fraction. So if you have forgotten how to do that, you flip the denominator and multiply. So we're going to multiply by sine theta over cosine theta. And we do that on the top and on the bottom. Okay? That's how you divide two fractions. Like I said, a lot of times you just have to know how to do math. So this is our fractions here. So these signs cancel, and we're left with 1 over cosine of theta. On the bottom, everything cancels, which is what we wanted. The sines cancel, and the cosines cancel. So we're left with 1 over cosine, which, if you look at your identities, we have another one right here. It says cosine equals 1 over secant. So here, 1 over cosine will equal secant of theta. And again, these are just interchangeable when you have fractions like this. Okay, what does that mean? That means you can change these two. Or these two, or these two. Okay, so sine theta equals 1 over cosecant theta, or you could say cosecant theta equals 1 over sine theta. That's all that's saying. Okay, it works both ways. All right, 2 more examples, and I'll let you try some on your own. Number 3, very, very classic problem here. Very, very simple problem, actually. Like I said, no squares, so Pythagorean identities are probably out. We're just going to change everything to sine and cosine. Cosine theta is already a cosine. Cosecant theta, right here, we can change that again using our identities. The reciprocal identity of cosecant is sine, so we're going to change that to 1 over sine theta. And then tangent, again, we can change it to 1 over tangent right here, but that's not sine and cosine. We want to use this one, where we're changing tangent to sine over cosine. Sine theta divided by cosine theta. All right, and now that you've got everything changed, it's just about simplifying. These sines, see how one's on top and one's on bottom? So they cancel. This cosines, one's on top and one's on bottom. So since you're multiplying, they also cancel. And you're just left with 1. And that problem is done. All right, last example. Cosine alpha times the cotangent of alpha plus the sine of alpha equals. So I think you're kind of getting the hang of it. Hopefully, we're going to change everything to sine and cosine. So cosine alpha, I'm going to change that cotangent alpha to cosine alpha divided by sine of alpha plus sine of alpha. And again, I'm using my quotient identity here. I'm changing cotangent theta to cosine over sine of theta. Over here, my variable is alpha, so I'm changing cotangent alpha to cosine alpha over sine of alpha. Okay? And then we do math again. Cosine times cosine would be cosine squared alpha divided by the sine of alpha plus, now, it's plus sine of alpha, but as you can see, we can't add these because, again, this is just basic math. You can't add two fractions that don't have like denominators. So we have to make it where it has a like denominator. So we're going to put under it a sine alpha. But if you put 1 under it, that means you also have to put 1 on top. Okay? So now my problem becomes cosine squared alpha plus sine squared alpha over sine of alpha. Okay? And now we have two squares. Remember what I told you about the square? When you see squares, you might want to look at your Pythagorean identities, which are right here. Okay? And you can see right there, it's the very first one, that sine squared theta, sine squared theta plus cosine squared theta equals 1. So up here, this whole top part is just 1. So that will be 1 over sine of alpha. And never, ever, ever leave your simplified answer. You're simplifying, remember, that's the direction, simplify. You don't want to ever leave it as a fraction because you can always do the reciprocal. So what is the reciprocal of 1 over sine alpha? Would be cosecant alpha. And that's it. That's 4 examples. Just before we leave, just a little heads up. These identities can all be used. There's more than just on this page. For example, here, the sine squared theta plus cosine squared theta. Yes, it does equals 1, but you can also rearrange it. You can also rearrange it where sine squared theta equals 1 minus cosine squared theta. Or you could rearrange it to where it says cosine squared theta equals 1 minus sine squared theta. So they are rearrangeable. You don't have to do it a certain way. It doesn't have to look exactly like it is. You can move things around if it helps. So hope this video helps. Hope y'all have a great day, and as always, stay above the line.